Okay, ladies and gentlemen, this is the Algebra 2 notes for 3.5. So, I want to show you a couple different ways to do systems with three variables. One's a little bit tougher, one lets the calculator do a lot of legwork for you. So, have a graphing calculator handy if you can. All right, so we'll skip the warm-up for right now, but take a look here. At the 2004 Summer Olympics in Athens, Greece, the United States won 103 medals. They won 6 more gold medals in bronze and 10 more silver medals in bronze. Write a system of 3 linear equations that can be used to determine how many each type of medal that the U.S. Olympians won. G is gold, S is silver, B is bronze. So altogether, G plus S plus B, they got 103 medals. So they won 6 more gold medals in bronze and 10 more silver medals in bronze. So however many bronze they had, however many bronze they had, they won 6 more than that to get gold. So that'll be B plus 6. And for silver, that'll be B plus 10. They won 10 more to 6 more. So how can I figure out how many of each type of medal the U.S. Olympians won? So this becomes kind of an extended version of substitution. Just because I've got G and S by itself here, it equals something, and it equals something with B, where B is a variable I already have in there. So this kind of gets rewritten as B plus 6. This represents kind of the gold, plus B plus 10. That's kind of your silver, plus the actual bronze is going to equal 103. So what I'm going to do here then is this. I'm going to put all this together. So I'm going to get 3B plus 16 equals 103. Subtract 16, subtract 16. 3B is going to equal 103 minus 16. Which is going to be 87. And divide that by 3. So B will equal 29. So that means they won 29 bronze. So if they won 29 bronze, then that means that they won 35 gold, just add 6. That means that they won 39 silver, just add 10. All right, but not all of them are quite like that. Okay, so if I've got 3 variables like this, where there's 3 legitimate variables and each one is, and each equation has got something in front of x, y, and z, what I've got to do is look to eliminate some things. Okay, so what I've got to do is pick one of these and totally, completely eliminate it. All right, so here's kind of where this is going to go. I like the idea of trying to eliminate x. Okay, so if I can eliminate x twice, then I've just got y and z to deal with, and then I can work backwards and figure out what x is. All right, so this first thing I'm going to do is I'm going to take just these bottom 2. So I'm going to kind of ignore this top one. I'm going to take these bottom 2 right here, and I'm going to subtract them. All right, and I'm going to do that for the express purpose of eliminating x. So 2x minus 2x is 0. Negative y minus negative 3y is going to be positive 2y. 3z minus a negative 5z is going to be plus 8z. Then negative 5 minus 27, that's going to be negative 32. So over here along the side, I'm going to write 2y plus 8z equals negative 32. Now the second thing I'm going to do is I'm going to use this top one, and either one of these other 2, it doesn't matter, but I'll just take the second one. And I'm going to do a little more elimination with that, but I'm going to eliminate x from there. So in order to do that, so if I got x plus 2y plus z equals 10, 2x minus y plus 3z equals a negative 5. So in order to do that, what I need to do is get the same thing in front of x. So what I'm going to do is I'm going to multiply this top one by a negative 2. Then I'm going to rewrite it underneath. So it'll be negative 2x minus 4y minus 2z equals negative 20. So now when I add this, I'm going to add because these 2 are opposite signs. here's what's going to happen. X's go away. Negative y plus negative 4y is negative 5y. 3z plus a negative 2z is just positive z. Negative 5 plus negative 20 is negative 25. So now I've got negative 5y plus z equals negative 25. Now I've got a small system here that I can handle pretty easily. So 2y plus 8z equals negative 32. 5y plus z equals negative 25. One of the first things I could do here is just divide everything by 2. So that'll give me y plus 4z equals a negative 16. And then it just becomes a matter of how do you want to solve it. So what I might do is do a little substitution. I might take y equals negative 4z minus 16. All I did was subtract 4z over. So now y equals this. So I might substitute that back up into this one. So it'll be negative 5 times negative 4y. I'm sorry, not there. Keep that. Negative 5y plus, no wait, I was right the first time. Negative 5 times negative 4z minus 16 plus z equals negative 25. So now I've got everything boiled down to just z. Okay, so now this becomes 20z. This becomes plus 80 plus z equals negative 25. So this becomes 21z, and then if I subtract that over, that becomes negative 105. So a little division, I get z to be negative, I think, 5. Yeah, z should be negative 5. 5 times 21 would give you 105 negative there. So z is negative 5. So I know I did a lot of work just to come up with that. Well, now work this back, okay? Take z equals negative 5 and work it back through and figure out what the other ones are. Well, if z equals negative 5, I'm going to put that right back in here because that's easy to do. Negative 5y plus negative 5 equals negative 25. So now when I bring that over, negative 5y equals negative 20. I get y to be positive 4. Then once I know that, well, I can plug it back into one of these up here, my original ones, and figure out what x is. So z is negative 5, y is 4. So it's going to be 2 times 4. So I can figure out what x is. So it'll be x plus 8 minus 5, so it's going to be x plus 3 equals 10. So x is going to equal 7. All right, now that's a hard way. That's a lot of work. There's a lot of places I can screw that up. So what I want to do is figure out an easy way to do that. All right, so what I want to do is this. Not the eraser. I want to let the calculator do a lot of this for me. All right, so let me break this down for you like this. There's a way to solve multiple systems called matrices, and here's kind of how matrices work. So I'll give you the short version. Matrices say if I take just the coefficients, so I take just what's in front of x, y, and z. All right, matrices say I can rewrite this like this. Okay, x goes first, y goes second, z goes in the third column. So another way to rewrite this system of equations is as a matrix like this. All right, these are all the x's, these are all the y's, these are all the z's. According to matrix multiplication, you would take 3 times x, 1 times y, 1 times z, negative 1 times x, and so on. So to solve this, I'm going to do what is called taking the inverse of this. So I want to take the inverse of this matrix, and what that does is just like an equation, this moves this whole thing over to the other side. So what I'm left with is this, x, y, z equals 3, 1, 1, negative 1, 2, negative 2, 4, negative 1, negative 3, to the inverse times 0 times negative 3 times 9. So if I can somehow figure out a way to multiply these, then I could figure out my answer pretty easy. And I could do it by hand, but why do it by hand when you can let the calculator do a lot of this for you, which is what I want to do. So this is your graphing calculator. I say you should have this handy. So if we go to the large screen, we'll quit out of this. So now I'm back to where I started. So I might move this around a little bit so I can see what I'm doing. So this is on the TI-84. On the Inspires, it's actually even a little bit easier. So I can show you how to do that. But on the 84, so down here it says where the X inverse button says, right above it is matrix. So I'm going to click on that. So this screen comes up. Okay. What I want to do is go over to edit. And I want to edit that first one. I want to make it a 3 by 3 like that. And what I'm going to do is put in that data. So I'm going to take 3, 1, 1, negative 1, 2, negative 2, 4, negative 1, negative 3. Like that. Okay, so that's my first matrix. All right, so now quit. Second mode, quits out of there, goes second, X inverse again for matrix. Okay, so A is the matrix we just built. We don't want to go back in and mess with that anymore right now. We got to make the second matrix. We got to make the matrix of 0, negative 3, and 9. All right, so I want that to be 3 by 1. So that's going to be 0, negative 3, and 9. All right, so now I've got matrix A, I've got matrix B representing the matrices I want. So here's what I do. I go to second matrix, A, inverse, second matrix, B. Like that. So just what I wrote down before. When I do that, I get 1, negative 2, and 1. So that means X is negative 1, Y is negative 2, Z is negative 1. This becomes 1, negative 2, negative 1. There's my answer. All right, so when I can do that, life becomes significantly easier. All right, so let me do it again for you. Once I get good at this, I can kind of just look at the problem and know what it's going to look like. All right, so just looking at the problem, I'm going to go second matrix, go over to edit, go over to edit. Come back here. And I want this to still be a 3 by 3. So it's going to go 4, negative 6, 4. Now what's it go? 6 or 5, negative 8, 10. Okay, so now there's my, I call it the coefficient matrix. So that's what I want. So quit out of that. Now go over to the other matrix. For B, I want it's still 3 by 1. And now I'm going to put in 12, 18, and 20. Now I'm going to do the multiplication part again. So you're going to go second matrix. You're not going to go over to edit. You're going to stay on names. You want A, inverse. Whoa, whoa, whoa. Don't do that. Don't do that. Come back here. Then you want second matrix B. So it says singular matrix. That's on purpose. What that tells you is that there is no solution. Okay? So that means that there is absolutely no solution for this one. Okay, so try this last one on your own and then ask a question in class about it. All right, let's take a look at this one word problem together. So the sum of three numbers is 20. The second number is 4 times the first, and the sum of the first and the third is 8. Okay, so let's go X, Y, Z for first, second, and third, and the sum of those is 20. The second number is 4 times the first. So 4 times X will give you Y. And the sum of the first and the third is 8. So X plus Z equals 8. Write and solve a system of 3 linear equations to find the numbers. Well, here's my 3 equations. So now here's what I would do. I would try and make everything in terms of x. So get x by itself where you can. So this will be 8. So x here, sorry, z here is going to be 8 minus x. Y already equals 4x. So I can rewrite this as x plus 4x plus 8 minus x equals 20. So that'll be 5x minus 8 minus x equals 20. So that'll be 4x minus 8 equals 20. So that means 4x will equal 28. So x is going to equal 7. Okay, so x is 7. Y is 4 times x. So that's going to be 7. That's going to be 20. So that means z is going to be 8 minus x. So z is going to be 1. Problem is that one doesn't work. I apologize. I made a mistake. Right here, the second number is 4 times the first. See what I did? I'm sorry. This was all correct. I made one slight mistake here. This should be plus 8x here, plus 8 here. So when I bring that over, it should be 12. X should, in fact, be 3. So this should be, x should be 3, y should be 12, and 8 minus 3 should be 5 for z. That works way better. All right. So talk about this. Let's talk about this one in class, but I'll at least kind of get you set up on it. Actually, try and solve this. I'll help you set it up, and then try and solve this and show me your answer in class. So there's 49,000 seats in the stadium. There's upper level, middle level, bottom level. So you've got upper level, middle level, bottom level. There's 49,000 seats. So then the number of seats in the middle and the bottom together equals the number of seats in the upper level. So M plus B equals U. So then you've got all the seats are sold. The total revenue is $1,419,500. So $20, $25 for the upper, $30 for the middle, $35 for the bottom. When it's all sold out, gets you this. So let's look and see kind of what you got here for your options. So kind of what I would do is this. If you're handy with the calculator, I would let the calculator do a lot of that for you. So I bring this middle one, I would bring u over. So I would have negative u plus m plus b equals 0. So then I would use this one, and this one, put that in a calculator and see what I get. So that'd be 1, 1, 1, negative 1, 1, 1, 25, 30, 35. And then over here, I'm going to have 49,000, 0, and the 1,419,500. See what you can do with that. See what you get for an answer. All right. This second one's another one we'll talk about in class, or skip it. But come and talk to me with questions.